Okay, today we're going to talk about the present value. Present value is more widely used than future value because it compares everything in today's term, like a set of cash flows uh, or an investment in today's term. When working with today, you have more certainty than working with the future. An example being, here we have two investments and we're thinking about which one is better. Both of them will have an initial investment of $1,000 going out today. And investment A offers $350, $500, and $500 for year 1, 2, and 3. And investment B offers $50, only $50 for year 1, for $50 for year 2, but it offers a very good outcome of $900 at year 3. Well, it's a problem of paying, you like it paying now or paying later. Let's go to the concept first, how we can compare them. As you did in your homework that you're already comparing everything in terms of present value, let's give a deeper look into how it works. So basically it tells us how much a set of future cash flows is worth today. So we have multiple things happening at different times. We just need to discount it into today's term. So the present value will be equal to the CF of 0, meaning that the cash flow at time 0. So at time 0, it is present. So we don't need to do any discounting. And plus the cash flow at time 1. At time 1, in order to move time from time 1 to time 0, you need to divide by the interest rate, 1 plus R. 1 divided by the 1 plus the interest rate. So this is the discount factor for discounting one period of time. You're dividing by 1 plus R. What if the cash flow happens at time 2? At time 2, you need to discount 2 periods in order for you to go back to the present. So 1 and 2, so that's why you divide it by 1 plus R squared. Similar thing happens for cash flow that happened at time 3, time 4, and etc. Let's again take a look why present value matters. By comparing different investments at the same time, which is time 0, well, the larger one's better. And also it's fair because it's all in today's dollars. We're not comparing apple to pears, apple to oranges by having money at different times. They're all discounted to today's time. And if the present value is positive, meaning that we're making money, if the present value is negative, then we're losing money from this investment. So we definitely should not invest. So that's what it calls to be the net present value. So let's compare the investment A and investment B at 0% interest rate, meaning that there's no interest rate. Money does not change value over time. That's what it means. So simply we just add them together, right? So all the 1 plus R's will be 1. So dividing by 1 is the original value. So we just add them up. Okay, investment B is better. They're all making money, but investment B is making more. So we choose investment B. What about 5% interest rate, you might ask? Okay, investment A is, well, you follow the formula, right? 350 at time 1 is only equal to 333.33. Well, similarly for all the others, you need to discount them, and okay, we reach the present value of 219.22. Same for investment B. Okay, we get the present value of 234.19, which is still larger than investment A. Okay, investment B is still better. You see, we have the initial cost, we have the present value of the future cash flows, we minus that, we get our net present value. Similar at 10% interest rate, it's the same calculation, you're just replacing every 1.05 by 1.10. There you have it. But you find out that the investment A is actually, now it's better than investment B. The net present value, but they're still making money. What about 15% interest rate? You require more interest rate. Your present value will become lower, you will find out. Actually, here, the investment B has a negative present value, meaning that you're better off, if you have a bank that pays 15% interest rate, you're better off just put that $1,000 in the bank rather than invest in investment B. But investment A still offers better, a positive net present value under 15% interest rate, so we should select investment A again. So let's see how interest rate will change our decision. At 0% interest rate, our best investment is B, and same for the 5%. But when interest rate go to 10%, we'll actually prefer investment A over B. What's the difference between A and B, you might ask? So at low interest rate, we favor high total returns, but in higher interest rate, we favor earlier cash flows. Note that the investment A has earlier cash flow. Investment B has a big sum of $900 in the end, like in year 3. So it's later compared to investment A. So in this example, the crossover occurs somewhere between 5% and 10%. So that's when we shift from B to A. Okay, here's an exercise. So we want to compare these two investments. Both you want to invest $2,000 in the beginning and you're getting different type of returns. Very similar. I want you to calculate the net present value of each investment at 3% interest rate, 8% interest rate, and 12% interest rate. And I want you to find out which investment is better at different interest rate and what is the rate when they are actually equal. You can't decide. There must be a tipping point, like the previous ones between 5% and 10%. This one may be a little bit different. What is the rate when they're equal, when they're indifferent? I can choose option A or I can choose option 2. They both make money. They both make the same amount of money. They have the same net present value. So you might want to ask, how do you solve for A, right? How do you solve for problem 3? Basically, as of now, you can plug in different rate to see when their present value is equal, or you can sort of use Python, right? By Python, you have an automatic machine that does the work. You just need to program it. Yeah, you have Python. And just let me know how that goes. If it doesn't work well, let me know on Discord. Let me know your progress and everything else. And I want you to progress through your project. That's why I create this exercise too. Let's say you want to save $Y for your college tuition. You have T years to save, and you can invest in a savings account that pays X% interest rate. How much do you need to save each year? Right? It's sort of a reverse process. What I want you to do now is to find your X, Y, and T. X can be found on the internet. Like you go to the TD website, or tell you how much the interest rate is and total cost of the tuition. You might look at your Toronto or any school that you like New York University, right? Something like that. And the T is the number of years till you start college. You know that. You know T, what T is. I don't need you to do problem 2 as of now, but just think about it. How much you roughly need to save each year. You can also use Python for this. But just give a think about question number 2. Focus on question 1. Formulate your own problem. Well, that's the end of the slides here. And just let me know when you have something to show me.